So section 6.1 is about angle measure. Our goal is to learn about it, the length of a circular arc, also called arc length, learn about the area of a circle sector, and talk about circular motion. Okay? Let's start out with the definition. The measure of an angle is the amount of rotation about the vertex required to move ray 1 onto ray 2. Okay? So that's taking an angle and figuring out how to go from here to here. That gives you your measure. Okay? 1 unit of measurement for angles is the degree. So definition. If a circle of radius 1 is drawn with the vertex of an angle at its center, then the measure of this angle in radians. Radians is also abbreviated as rad. That is the length of the arc that subtends the angle. Okay? So we've talked about the unit circle. How to go from 0 to pi over 2 is in radians. Okay? How to go from 0 to pi over 4, that's in radians as well. Okay? The relationship between degrees and radians is as follows. And this is helpful because it tells you how to convert angles of measure from degrees to radians and from radians to degrees. So 180 degrees is the same thing as pi radians. 1 radian is equal to 180 over pi degrees. 1 degree is equal to pi over 180 radians. Now, to convert degrees to radians, multiply by pi over 180. Multiply whatever degree you're given by pi over 180. To convert radians to degrees, multiply by 180 over pi. So if I give you a degree and I ask you to convert that degree to radians, what do you need to multiply that degree by? Pi over 180, you got it. Good. If we want to convert radians to degrees, so if I give you a radian measure and I ask you to convert that to degrees, what do you multiply that by? 180 over pi. Excellent. So now what we're going to do is we're going to go through some examples where we do those conversions. Okay? You need another second here? Okay. I'm going to move this up so you can see it. All right. So some examples. Example 1, we want to find the radian measure of the angle with the given degree measure. Round your answer to 3 decimal places. So we're going from degrees to what? Radians. So we need to multiply 36 by what? Good. So multiply that by pi over 180 degrees. That would really be radians there. And being loose with the degrees, you'll see your book write it a lot, but typically whenever we're just doing conversions, we know that we're going from degrees to radians. Okay? But I'm writing it to stay consistent. Now, 36 over 180. 36 goes into 180 how many times? So that would be 36 pi over 180, right? That's 36 pi over 180 radians. But what is 36 over 180? 1/5. Good. So you get pi over 5 radians. Or to 3 decimal places, what do you get? Good. 0.628. And you put radians there. And that's your final answer. What questions do you have? Convert 200 degrees to radians and round your answer to 3 decimal places. 200 times 200 degrees times pi over 180. What do you get? Before you provide a decimal, what do you get?
10 pi over 9.
Good, you get 10 pi over 9 radians. Very good, or?
3.491.
You got it. Good, 3.491. Good. Okay, example 2. Example 2, we want to find the degree measure of the angle with the given radian measure. So, we're going from radians to degrees. So we need to multiply what we're given by what? 180 over pi. Good. So you have 3.14 is going to be equal to 3.14. I said 3.14. I'm thinking pi. No, we have 3.4 times 180 degrees over pi. That's equal to 180 times 3.4 is what? 612. So good. So you have 612 degrees over pi. And what is that approximately in terms of degrees? To 1/10 of a decimal place.
194.8.
Good. Good. 194.8 degrees. Okay? Excellent. Part B. You have negative 13 pi over 12. You have negative 13 pi over 12. Would you like a minute to try it? Heads nodding yes. Go. You have negative 13 pi over 12. Walk me through the steps. Online, what do we do here? This is open for everyone to answer. What do we do?
You start by multiplying by 180 degrees over pi.
Good. Good. You have negative 13 pi over 12, and you said multiply it by 180 over pi. 180 degrees over pi. And then you simplify that. What do you end up with?
Negative 2340 over 12, which reduces to negative 195.
Negative 195 degrees. Very good. Very good. What questions do you have? Okay. Let's talk about two angles in standard position. So suppose we start out with two angles in standard position. These are coterminal. They are coterminal if their sides coincide. So, for example, here is an angle there. This angle is a coterminal angle. That angle is a coterminal angle. Okay? So their sides coincide. What questions do you have? Do you have this? Okay. Some examples here. In example 3, we want or we will start out by saying that the measure of an angle in standard position is given. Find two positive angles and two negative angles that are coterminal with the given angle. So you're given 135 degrees in standard position. So we want to find two positive angles. So for the positive angles, we'll take 135. We can add what to it? 360. Good. Adding that, we get 495 degrees. That's one coterminal angle. Now, we can take 135 and add 720 degrees to it. That means we're going around twice, right? So whenever we do that, that'll give us another positive coterminal angle. So 135 degrees plus 720, what does that give us?
855 degrees.
Good. That's another positive angle that's coterminal to 135. Find two negative ones. Find two negative coterminal angles to 135 degrees. So what two negative angles did you come up with?
-225 and -585.
Good. Negative 225 degrees and negative 585 degrees are two. So you have 135 degrees minus 360. That gave you negative 225, as you said. Good. And then you took another one, 135 degrees, subtracted 720 degrees, and you get negative 585 degrees, as you said. Or you can just take negative 225 degrees and subtract 360. You get another coterminal angle, which is negative 585. So that's just an alternate way. There are other possible answers. These are just two. Okay, two positive and two negative. Same idea if you are given radians. It's the same thing, but instead of adding 360, you're adding what?
2 pi.
2 pi. Good. You're adding 2 pi. Or you're adding 4 pi. Or you're subtracting 2 pi. Or you're subtracting 4 pi. Okay? Or multiples of 2 pi. Okay, so part B. Part B, you're given 11 pi over 6, and we need to find two positive coterminal angles and two negative coterminal angles. So, for the positive ones, we can take 11 pi over 6 and add 2 pi to that. Adding 2 pi is the same thing as saying, hey, you have 11 pi over 6 plus 12 pi over 6, because that's 2 pi. You get 23 pi over 6. That's one positive angle that's coterminal to 11 pi over 6. Then you can take 11 pi over 6, add to it 4 pi. How do you rewrite 4 pi?
24 pi over 6.
You got it. So plus 24 pi over 6. Very good. That leaves you with what?
35 pi over 6.
You got it. So those here are two positive coterminal angles to 11 pi over 6. Would you like a minute to find two negative? Okay, I'll give you a couple minutes to find two negative coterminal angles. What are two negative coterminal angles?
-pi over 6 and -13 pi over 6.
Very good. Negative pi over 6 and negative 13 pi over 6. Very good. So negative pi over 6 and negative 13 pi over 6. So again, if you want to see how you get it, you take 11 pi over 6, subtract 2 pi, that'll give you the first one, and then take 11 pi over 6 and subtract 4 pi, that'll give you the second one. What questions do you have? All right, so let's go over another example. We want to find an angle between 0 degrees and 360 degrees that is coterminal with the given angle. Okay? So, what would it be? 260. How'd you get it?
Just add the 360.
Very good. 260 degrees. And we got it since negative 100 plus 360 degrees is equal to 260 degrees. Good. In some examples, you'll be given a larger number, right? And if you're given a larger degrees, I say number, but you're given a larger degree. If you're given a larger degree and you need to find an angle between 0 and 360 degrees, what are you going to do? How do you find an angle that's coterminal with that one between 0 and 360? You would subtract. Good. You would subtract 360. You subtract multiples of 2 pi if it's radians.
You repeat that?
Yes. So, if you want to find an angle between 0 degrees and 360 degrees that's coterminal with an angle that has a larger degree. So, for example, if you have 1,260 degrees and you want to find an angle between 0 and 360 degrees that's coterminal with that, you would have to subtract 360. Subtract multiples of 360.
Until you get to an angle between 0 and
Ze-
360?
That's right.
Okay.
Until you get to an angle between 0 and 360. Now, there's some other ways that you can do it. Like you can take the number and you can divide it by 360 and you can look at the remainder. You can do that as well. Okay. Another example, same idea, but just in terms of radians. Radians, not degrees. Okay? So, find an angle between 0 and 2 pi that is coterminal with the given angle. Find an angle between 0 and 2 pi that is coterminal with the given angle. Very good. How did you get it?
I saw 51 pi over 2 as 25 pi plus pi over 2.
51 pi over 2, you wrote as
25 pi plus pi over 2.
25 pi plus pi over 2.
And then it's, so the 25 pi is 24 revolutions plus half a revolution. And then an additional quarter of a revolution, which is 3 pi over 2.
Good. So say that one more time. You had 25 pi plus pi over 2, and then
You make the 25 pi. You make 12 revolutions.
because so the 25 pi, you said that's 12 revolutions.
Plus an additional half revolution because of
You said 12 plus a half.
yeah, because it's 12 revolutions plus.
So you're going around 12 times,
Yes, plus.
and then
half
you're going to go around a half, right?
Yes.
Good.
Plus another quarter revolution.
So then you add a quarter to that, and then you end up here. Good. Good. So you can erase this, because what you're thinking of is graphically. So here, and then you end up at 3 pi over 2. Very good. Okay? Now let's talk about the length of a circular arc. A lot of books you'll see this called arc length. Okay? Let's talk about the length of a circular arc. So, in a circle of radius r, the length s of an arc that subtends a central angle of theta radians is s equals theta times r. Graphically, let's put it together. You have a circle. Circle has radius what? Nope. No. What does it say? In a circle of radius r. Yes, we have a circle of radius r. Okay? The length s of an arc. So we have an arc, and then we have the length s here. Okay? That subtends a central angle of theta radians. So theta here. So this says that s is equal to theta times r. S is equal to theta times r. Okay? Now, solving for theta, if we solve this for theta, what do we get?
S divided by R.
Good. Theta would be equal to S over R. This is a very useful formula here that we have in this box, because what it does is it allows us to define radian measure using a circle of any radius r. It allows us to define radian measure using a circle of any radius r. Okay? So now what we're going to do, we are going to find the length S of the arc that subtends a central angle of measure 40 degrees in a circle of radius 12 meters. Let me ask you a question. Here, theta is in what?
Radians.
What did I give you theta in terms of here? Degrees. So what are you going to have to do? Transfer or convert that to radians, right? So, first things first, you might want to convert this to radians, or what you can do is you can do it all at one time if you want. Do you want to do that first, or do you want to do it all at once?
Let's do that first.
Do that first? Okay, so convert 40 degrees to radians. Would you like a minute? Okay, so you said you were going to convert 40 degrees first to radians. So 40 degrees, we need to multiply by what? Pi over 180. Good. And then that gives us what? 2 pi over 1? 2 pi over 9. Okay. What do we leave off? We should have what? Radians, right? Good. Okay. So now we've converted that to radians. Now, whenever we want to find S, S is equal to R times theta. This is equal to what?
12 times 2 pi over 9.
12 times 2 pi over 9. Good. That's equal to what?
Approximately 8.378.
Good. Let's write it as a fraction first. That'll give us 24 pi over 9.
Which is 8 pi over 3.
Good, which is 8 pi over 3. And you need to be, and the only reason why we're doing this, because you'll need to be able to identify it both ways. Okay? So, and then in decimal format, you said it was 8.378?
Yes.
Okay, so 8.378 meters, right? And we don't need to write radians here, because note that it says a circle of radius 12 meters, so here, this should be meters. Eraser. Because remember, you're finding the length. Okay? Example 7. Example 7. An arc of length 15 feet subtends a central angle theta in a circle of radius 9 feet. Find the measure of theta in degrees and in radians. So what is theta? What's your formula?
Theta equals S over R.
Good. Theta's S over R. So it's equal to what for us?
15 over 9.
15 over 9. Good. Or 5 over 3. And this is in terms of what?
Degrees,
Radians. Radians.
Oh, yes.
Radians. Right. Good. That's in terms of radians. That's why I had to ask the question, because remember that formula gives us the way for finding that in radians. Now, once you have this is in radians, you can now convert it to degrees. How would you convert that to degrees?
Multiplied by 180 over 5.
Good. So you have that time, or 5/3 times 180 over pi. And that's approximately what to the nearest tenth?
286.5.
Whoa. Say it again.
286.5.
Try it again. You have 5 over 3 times 180 over pi.
95.5.
95.5 is what you should have. Good. 95.5 degrees. So you have 5/3 radians or 95.5 degrees. Okay? Now, the area of a circular sector is given by the following formula. In a circle of radius r, the area A of a sector with a central angle of theta radians is A equals 1/2 r squared theta. So what's happening here is you have this sector here, and the area of that is just this shaded part. So whenever you go through problems, you will have homework problems that you will have to find the area of a circular sector. You use this formula to find it. Okay? Definition: linear speed. Linear speed is the rate at which the distance traveled is changing. So in other words, it is the distance traveled divided by the time elapsed. It's the distance traveled divided by the time elapsed. Okay? Angular speed is the rate at which the central angle theta is changing. So it is the number of radians this angle changes divided by the time elapsed. So, graphically, what's happening? Graphically, we have a point. So, I'll draw the following. You have your radius r, and I'll give you time to draw it if you just want to pay attention. You have your radius r, and then you have this angle that's created by taking this point and moving it along to this. Okay? So you have a point moving along a circle. You have a point moving along a circle. And then you can ask questions about the linear speed and the angular speed. So it's all coming from moving that point. Okay? So just to formalize, put the math formulas with these concepts, that's on the next page. Linear speed and angular speed. Suppose a point moves along a circle of radius r, and the ray from the center of the circle to the point traverses theta radians in time t. Let s be equal to r times theta, so you have your length. Let that be the distance the point travels in time t. Then the speed of the object is given by the following. The angular speed is given by omega equals theta over 2. Omega equals theta over, I said 2, but t. Okay? Omega equals theta over t. That should not be 2. I said 2, but it should be t. Omega is equal to theta over t. So your radians over your time. Your linear speed is v equals s over t. Okay? So, let's look at an example. Did you have a question? Okay. So let's look at an example. A radial saw. Radial means it's what? A circle, right? A radial saw has a blade with a 6-inch radius. Suppose that the blade spins at 1,000, what is this? Revolutions per minute. 1,000 revolutions per minute. Okay? A, we want to find the angular speed of the blade in radians per minute. Okay, so for part A, the angular speed is omega equals theta over t. It's omega equals theta over t. Now, theta here is equal to 1,000. Now it's changing, so it's in a circle, so we have to account for that. So 1,000 times 2 pi radians per minute. So that's equal to 2,000 pi radians per minute. That's your angular speed. Part B, we need to find the linear speed of the saw teeth in feet per second. So now this is a little bit more work here because we're given our information in terms of what? Radians, yes. And here, your radius is in terms of what? Inches. We want our final answer in terms of feet per second. Okay? So we have to make sure we remember some conversions here. So remember, your linear speed is equal to, V is equal to S over T, which is equal to theta times R over T. Theta is 1,000 times 2 pi, but our radius is 6 inches, but we want it to be feet, so 6 over 12.
So it's 1/2?
Yes, 1/2, yes. I'm gonna write 6 over 12 so you can see the actual numbers, but 1/2 is exactly what you should write. So 6 over 12 here, and that's your radius because it's in inches, but we need it feet. Okay? Now we're going to divide it by our time. Our time was 1 minute, but we want in terms of seconds. So this should be divided by?
66.
Very good. Divide that by 60. Very good. So you go through and you simplify this. You will get, so here as a fraction, you will have 50 pi over 3 feet per second, or as you said, 52.4 feet per second. What questions do you have?
For linear speed for the equation, what is V?
That's just what we tend to think. We just write V. A lot of time we're thinking velocity.
That's what I thought.
We're thinking velocity. Your book doesn't go through and explain that, but we're thinking velocity. That's a good question. It's a good question. And it's really neat because you can then connect this to ideas that you learn in calculus in terms of your derivative. What other questions do you have? Okay. Now let's move this down. That comes from taking, you have V is equal to S over T, and then you can substitute that in here, solve it. The way you can actually relate the two, there's a way that you can relate angular speed and linear speed. If a point moves along a circle of radius r with angular speed omega, then its linear speed v is given by v equals r times omega. So that comes, and you get R times omega. Okay? So let's talk about that in terms of the speed of a car. You can also, another common example is looking at the spokes of a bicycle wheel, and then you're talking about it moving. Okay, so you'll see examples like that in your homework. Okay, so the wheels of a car have radius 11 inches and are rotating at 600 revolutions per minute. Find the speed of the car in miles per hour. Now here you have to remember quite a bit. So this is miles per hour. That's an H, not an N. That's an H, not an N. So some things that you'll need to remember here. 12 inches per foot. (5,280 feet per mile. And 60 minutes per what?
An hour.
Good, per hour. Okay, so V is equal to R times omega. Okay, well, V would be, we have our 600 revolutions per minute. So 600 times 2 pi. And then you're given a radius of what? 11 inches, but we have to remember we need to use feet. So that should be, we should multiply our numerator by what?
11 over 12.
Good, 11 over 12 feet. And then that's per minute. But then we have to multiply all of that. Remember, 1 mile is 5,280 feet. And then we have to multiply that. So notice that this would allow the feet to cancel. And now we want what to cancel? The mile? No, we don't want the mile. We want to end up with miles per hour. We want to cancel the what? What pi? No? We want to cancel the minutes, right? So what else do we need to multiply by? 60 minutes per hour. So 60 minutes per hour. And that will cancel the minute. So then you go through and evaluate. Do you want a minute to evaluate it? Okay, go. So you would end up with 39.3 what? Miles per hour. Okay? Or you'd have 12.5 miles per hour. Either one. No. 12.5 over what? Ignore that part. There's no or. Leave it alone. Doesn't make sense. Change an answer. I wanted to try and give you the rational expression as well, but you're good. What other questions do you have? Okay. So this concludes our section on angle measure.